Hello, this is the second to last topic video that I have to make, not have to, but I'm choosing to make. So that's slightly exciting. After this, I have cylindrical integration left, so that'll be a little bit more of a challenge to get through and edit and everything. But for now, we're stuck with the multivariate chain rule, which is not too bad. We know that if we have a multivariable function that is, in this case, it's p, so let's just call it p, and that function is a function of multiple variables. In this case, it's u, v, and w, and each of these variables is a function of some other variables. In this case, each one is composed of x and y. Then we know here where u is a function, where u, v, and w are functions of x and y, then we know that, let's say, px is going to be equal to the partial derivative of p with respect to u times the partial derivative of u with respect to x, plus the partial derivative of p with respect to v times the partial derivative of v with respect to x, and then plus the partial derivative of p with respect to w times the partial derivative of w with respect to x. So all of these questions, it's pretty much finding and filling in 4 or 6 blanks in order to solve these questions. So let's figure this thing out. First of all, we're going to need a little more space, and we'll just remember the blanks that we have to fill in, because I'm probably going to need all of this space here. So first of all, let's figure out what u of 0, 1, v of 0, 1, and w of 0, 1 are equal to. So we know that this is our x value and our y value here. So if x is 0 and y is 1, well, we know that, where is it? I hate how this question organizes their information. Well, we're given that u of 0, 1 is 0. And so that's nice. We also see that w of 0, 1 is 2, and that v is given by y e to the x. And so that's going to be 1 e to the 0, or just 1. And so these values are going to help us because when we take our partial derivatives of u, v, and w, we will need these values. Oh, sorry. No. Well, what I really mean, I thought something was off. When we take our partial derivatives of p, we will need these values because we need to plug something in for u, v, and w, and these are going to be what we use to plug in there. So let's find pu, pv, and pw. These end up being pretty simple. We're just going to get u over root u squared plus v squared plus w squared. We will get v over root u squared plus v squared plus w squared, and we will get w over root u squared plus v squared plus w squared. And in this case, u plus v plus u squared plus v squared plus w is just going to be 5, and so the square root of that is just going to give us root 5. And so we can actually solve these. This is just going to be 0 because we will get 0 over root 5 because we know that u is equal to 0 here. We will also see that v over here is going to be 1 over root 5, and down here we will get 2 over root 5. And we're actually halfway done with our question, and because we can set this up as px is equal to, well, pu, which is 0, times ux, and then we're adding PV, which is 1 over root 5 times Vx, and to that we're adding 2 over root 5 times Wx. And this gets nice and easy, nice and quick, because we're given here that Wx at 0, 1 is equal to 0. So we can substitute that in, and we see that no matter what ux, no matter what ux is equal to, no matter what this is over here, both of these components are going to be 0. So px is really just equal to 1 over root 5 times vx. And we'll have to find vx from here. Well, vx is just going to be y e to the x. And we know that y e to the x at 0, 1 is going to be equal to 1. And so px overall is 1 over root 5 times 1. And that gives us our 5 to the negative 1/2, which is our answer. Okay, a little easier, a little less cluttered question that we've got here. We're looking for dz dt. We see that z is made out of x and y, and that x and y are each made out of t. And so we're dealing with far fewer values here. We will see that dz dt is going to be equal to zx xt plus zy yt, evaluated for t is equal to 1. And these y values, or everything to do with y over here, is simplified because we know that y is just some function h of t, where h of 1 is 1/3, so we will say that y is equal to 1/3 in this case. But importantly, the derivative, so y of t, is going to be equal to 2. So we can already say that y of t in here is equal to 2. And then it's just a matter of finding our zx and zy, which will each be y cosine xy and x cosine xy. We know that y is equal to 1/3 and that t is equal to 1, so x is equal to pi. So we can solve this. We're going to get 1/3 times the cosine of pi over 3. Well, the cosine of pi over 3 is going to be 1/2. And then over here, we're going to get pi times 1/2. So overall, we get 1/6 and pi over 2 like that. So now we can replace these guys. Our zx is 1/6, and our zy is, it looks like an m, is pi over 2. It still looks like an m. And finally, all we need is our xt, which is going to be, let's see, xt is a partial derivative of x with respect to t. That'll give us 2 pi t. For t is equal to 1, xt is just 2 pi. And now all we have to do is replace that in here with 2 pi, and we will get pi over 3 plus pi, which is 4 pi over 3. Let's suppose that this function has the following properties, where we're given some, looks like we're given some partial derivatives, and we are given what x and y are composed of in terms of s and t, and it looks like we're looking for fs. So fs, we know by the multivariable chain rule that this is going to be fx xs plus fy ys. And one thing that they will commonly do with these questions is give you duplicate sets of values. So we are given values for the ordered pair 0, 0 and the ordered pair 1, 1. And we know that these are our values of x and y, because f is composed of x and y over here, and we know that they are not directly values for s and t, so they will always give you values of x and y or whatever, like secondary, well, because you can kind of view this as f, and then we go down a layer and we have x and y, and then we go down a layer and then we have s and that's another s and t. So they will give you a set that matches your third step ordered pair. But remember, this is for our second step. This is for x and y. So it will usually almost never be correct to choose the one that matches here, but we can prove that by plugging these in. So we see that x is equal to e to the s minus t e to the t. If we plug in 0, 0 to that, we will get x equals 1. And then the same thing goes for y. We will get y equals 1 when we plug 0, 0 in. So we know that we can be confident in completely crossing off these two and only dealing with that 3 and that 7, which we can directly substitute in. We know that 3 is going to be here, and 7 is going to go there. So now all that's left to do is find our xs, which will be e to the s, and our ys, which will be negative e to the s minus se to the s. And when we evaluate this at 0, 0, we will get 1 and negative 1. And substituting this in, 3 times 1 plus 7 times negative 1, we will get negative 4. Let's let x equal, sorry, that's not an x, that's a z. Let's let z equal the function f of x and y, where fx is this thing, fy is this thing, x is this thing, and y is this thing. And we're looking for z of t, which we can, I'd prefer to call this f of t, at s and t at 2 and 1. So we know, again, by the multivariable chain rule, this can be expressed as fx times xt plus fy times yt. And we just need to fill in these 4 blanks. So first off, so that we can kind of solve our fx and fy, we need to figure out what x and y are equal to. So x is equal to s plus 2t, and when s is 2 and t is 1, this is going to give us 4, and this y is just going to give us 1. So using this, knowing this, we can move over to our fx and fy and see that fx is equal to xy squared is equal to 4. And the same goes for fy. This is going to be x squared y, so 16 plus y squared, which is 1, so 17. And at this point, we might as well just find our xt and yt and get this whole thing over with. Xt is going to be 2, yt is going to be 2t, and since we know that t is equal to 1, this is going to be equal to 2. And so finally, we can work everything out. We are going to get fx times xt, which is 8, plus fy times yt, which is 34. And this will give us an answer of 42. Oh, I love these where they give us everything we need in a nice little table. So we are supposed to use the table below to find GV. Well, what's GV going to be equal to? We see that GV is a function composed of, GV is equal to f of this guy, comma this guy. And so we can kind of pull this out here. This first component is going to be x, so our x component is u plus 2v cubed plus 1, and our y component is e to the uv minus 1. So gv is going to be fx xv plus fy yv. And let's see how much of this information we get from the table. As it turns out, it's not everything, but again, they're trying to trick us with this because gv at -1, comma 0, we know that that -1, comma 0 is for x, and oh, sorry, haha, it's 11, 12, and 9. I'm kind of going crazy. Those values are for u and v because we see that G is composed of u and v. So when u is equal to -1 and v is equal to 0, we can solve for what x and y are going to be for this ordered pair that they're giving us here. Well, in the case of x, we're going to get -1 because this will work out to -1 cubed. Oh, sorry, got ahead of myself again. We're going to get -1 cubed plus 1. So x is equal to 0, and over here we are going to get another 0. We will get 1 minus 1, so y is also equal to 0. Okay, enough mistakes for now. So we know that we want to be using the ordered pair or the fx and fy values that correspond with 0, 0. So we can rewrite gv as 5, replacing that for fx that we found here, xv plus 7 yv. So let's find xv and yv. So evaluating our xv and yv, our xv is going to be 6u plus 2v squared, which will evaluate out to 6 when we apply these things that we know over here. And then our yv is going to be ue to the uv, which is -1. Oops. I did have to do another take. I took a derivative of -1 and got -1, so we're here. So we can replace this xv with 6 and this yv with -1, and this whole thing works out to, by 33, I mean 23. Okay, this, as far as exam 1 questions go, this did show up on an exam 1. This is an extremely scary looking question. We have a function, they're telling us it's differentiable, we have some partial derivatives, we have gamma of t, and it's composed of things, and we're looking at the derivative of gamma with respect to t, and oh no, okay, so really this is just a multivariable chain rule question in disguise, and it's easier than, once you realize that it's multivariable chain rule, it's easier than pretty much every single other one because, okay, so let's think through this. We have a function f of x, y, and z. We are given its partial derivatives at 1, 1, 1. Then we have another vector valued function, gamma of t, and it is the parametric equation of a differentiable curve in R3. And let's suppose that gamma of 0 is equal to 1, 1, 1. And we're also told that the derivative, we're given our derivative here. And then we're trying to find the derivative with respect to t of gamma composed into f. And this is a perfect case for the multivariable chain rule. All that needs to be true is that the data that we're given for gamma of 0, we need that to give us the same ordered pair that they're checking up here. And in fact, it does. So all this is asking us for this dt f of gamma, that's a terrible gamma, of t, all this is going to be is fx, oh no, I have to draw 3 gammas, gamma x plus Fy gamma y plus Fz, that's a huge Z, gamma z, just like normal. And so this is really just going to be a dot product, kind of, you can kind of think of it that way, between -6, 2, and -1, and the three things that were given, come on, eraser, the three things that were given down here. So we're going to have -6 times 3, which is -18, minus 6, minus 1, which will give us our answer, which is -25. But if this question did come up on the exam, it would be extremely scary. This is a very scary question, just to kind of wrap your head around. For exam one, probably pretty scary, but for the final, we've seen a lot of stuff since then, so maybe a little less so. Okay, last two questions. We are given that z is equal to z as a function of x, y, and t, where x is a function of u, v, and w, y is a function of u, v, and w, and so is t. And then we're given a bunch of other stuff when we're told to find zv. Well, since z is composed of x, y, and t, and each of those are composed of u, v, and w, we know that this is going to be equal to zx, xv, plus zy, yv, plus zz, oh sorry, they call it t, zt, tv. And let's find these 6 blanks and figure all this out. Zx is going to be e to the ty, zy will be tx e to the ty, and zt will be xy e to the ty. We know that u is -2, v is 1, and w is 2 from over here, so we can solve for x, y, and t, which will let us solve for these guys. X is u squared plus v, so 4 plus 1 is 5. Y is vw, so 2 plus u, which is -2, so 0. And t is w squared u, which is just going to be w squared 4 times -2 is -8. And so given that, our zx is going to be 1, our zy is going to be -40, and our zt will be 0. So there we go, we're halfway done, and since we found that zt is equal to 0, we don't even need to find tv. That whole part of our expression is equal to 0, and let's go replace some things. This is 1, and this is -40. And all we have left to find is our our v, oh my god, our xv and our yv. xv, yv, where xv is our partial derivative of x with respect to v, that'll just give us 1, and yv, which will give us w, which we know to be equal to 2. And so putting everything together, we get a 1 times 1, and we get a -40 times 2. And so 1 minus 80 is going to be -79. Okay, final question. Same thing as usual. And it's kind of a tradition for me now. Let's try to do this question as fast as possible so that I can edit these and upload the things I've done tonight and go to sleep. Okay, so fx is going to be 8x to the 7th y squared. Fy is going to be 2x to the 8th y. We know that x is this, so what are we looking for? We're looking for the derivative with respect to v, so xv is going to be 2, yv is u cosine uv, where u is 1/6 and v is pi, so the cosine of pi over 6, cosine of pi over 6 is going to be √3/2 root 3 over 2 times u is going to be root 3 over 12. And then over here, this is still equal to 2. And, okay, what are x and y? We know that x is going to be 12u. X is 12u, so 2 plus 2 pi. And we know that y is going to be the sine of pi over 6, which will be 1/2. Okay, so we can now solve for fx. Fx is going to be 8, 2 plus 2 pi to the 7th plus 1/2 squared, so 1/4, so this is just going to be 2. And then fy will work out to 1/2 times 2, so just 2 plus 2 pi to the 8th. And then all we're doing is bringing this guy down in here and this guy down in here, and we will get 4, 2 plus 2 pi to the 7th plus root 3 over 12, 2 plus 2 pi to the 8th, which is answer number, answer E. Okay, hope this was helpful. I kind of hate this topic. It makes me uncomfortable feeling like I'm losing values, and sometimes they express things in really weird and scary ways, but other than that,